IEEE RAIT, where you learn new things in each video. In the last Arduino video, we have explored Arduino programming and had a little hands-on action too. If you have missed it, the link is in the description below. By now, you must have searched a lot of Arduino projects and can't wait to get your hands on projects like Arduino motion sensor or camera security systems. However, before we start all these amazing projects, we need to understand what these sensors are and how exactly they work. We need to explore these sensors fully to understand how to program them and which ones we have to use in our projects. So, let's dive into the world of sensors. Sensors, detectors or transducers are electronic components made out of various materials. These sensors are used to record digital or analog readings of different physical or real-life phenomena like detecting day or light, whether it's raining or not, or the temperature, or if a person is moving. These sensors help us trigger a digital activity when some action is completed in the physical world. There are a lot of sensors which are classified on various criteria like active or passive based on means of detection used in the sensor, based on conversion phenomena, or as analog or digital sensors. Today we are going to dive into the sensors based on infrared technology, which are the active infrared sensor and the passive infrared sensor, commonly known as PIR sensor. Let's have a look at the active infrared sensor. IR technology is used in our daily lives as well as industries in a lot of things like our TV remotes. An infrared sensor works on the basis of infrared radiation. Usually the wavelengths of these waves ranges from 0.7 micron to 1000 micron. These types of radiations are invisible to our eyes, which can be detected by an infrared sensor. An active infrared sensor consists of two LEDs, an emitter, which is an IR LED, and a receiver, which is an IR photodiode, which is sensitive to IR light of the same wavelength as emitted by the IR LED. IR LED is one kind of transmitter that emits IR radiations. This is an IR module. It has two transmitting and receiving LEDs in the front. It also has the NE555 timer IC on board with a rheostat to adjust the distance sensitivity. Along with this, it also has two LEDs on board, of which one is the power LED while the other is the obstacle LED, which turns on if there is any obstacle in the path of the transmitted infrared light. On the other side of the module are three pins, which are used to connect the module to the Arduino. These pins are the VCC, ground and the data pins. These sensors are very useful and beginner friendly and are easily available in any electronic shops. Now that we have understood the active infrared sensor, let's take a look at the passive infrared sensor or the PIR sensor. The PIR sensor's principle is similar to the active IR sensor. However, these sensors allow you to sense motion, almost always used to detect whether a human has moved in or out of the sensor's range. They are small, inexpensive, low power, easy to use and don't wear out. For this reason, they are commonly found in appliances and gadgets used in homes or businesses. PIRs are made up of Pyroelectric Sensor, which you can see below, as the round metal can with a rectangular crystal in the center, which can detect levels of infrared radiation. A pyroelectric sensor is a type of infrared sensitive heat-based sensor. This helps us to detect the change in motion and not the average IR levels. The white dome on the top of the sensor is a Fresnel lens. A Fresnel lens is a lens that has a surface consisting of a concentric series of simple lens sections. This is used to lengthen the detection distance of the detector. On the back of the PIR sensor, we can see the BISS 0001 PIR chip, a 3V DC regulator, a retrigger setting jumper and two rheostats for varying the delay time and the sensitivity respectively. There are three pins, namely VCC, ground and the digital output, to provide power to the module and receive data from the module respectively. The retrigger setting jumpers are used to configure the sensor in retrigger mode or the normal mode. A continuous motion results in a repeated high-low pulse. As we can see, this sensor is a very powerful and useful sensor and is used in a variety of projects and places to detect change in motion. Hope you enjoyed this video and learn a lot about these sensors. We'll meet again in our next video where we'll get a taste of what the Node MCU is. Till then, stay tuned.